درود دوستان، امیدوارم حالتون خوب باشه. من امروز قصد دارم در رابطه با ارتباط بالانس و آنبالانس بین کیبورد و دیوایس های دیگه مثل میکسرها، ساند کارت ها و دستگاه های دیگه براتون یه توضیح بدم. ببینید اهمیت این موضوع وقتی شکل میگیره که شما هم خروجی بالانس داشته باشید هم ورودی بالانس. یعنی همین که شما کیبوردتون خروجی بالانس داشته باشه و به اون دستگاهی هم که میخواید وصل بکنی ورودی بالانس رو داشته باشه. حالا بالانس و آنبالانس چی هست؟ ببینید اکثر شما اگر الان کابلیو که دارید استفاده میکنید برین بررسی کنین، سرفیشاش از این جک های TS هست. خب اگر کیبورد شما خروجی بالانس رو ساپورت نمیکنه که هیچ مشکلی نیست. اما اگر کیبورد شما خروجی بالانس داره و آن بالانس نیست، حتما سعی کنید از این نمونه سرفیش ها برای خودتون کابل درست کنید یا اینکه آماده اونها رو بخرید. حالا تفاوت این چی هست؟ ببینید من اینو اگر باز کنم، برخلاف سرفیش های آن بالانس 3 تا جای لحیم ما داریم اینجا که یه دونه گراند یا همون بدنه حساب میشه، یه دونه به اصطلاح منفی و یه دونه هم مثبت. اکثر کیبورد های کورد مخصوصا سری های X از PA1 تا PA5 همه 100% خروجی بالانس رو دارند. یعنی شما باید از فیشی استفاده کنید که به صورت TRS باشه. الان هم ببینید این فیش، حالا این دو سرش تا حالت L هست، این دو سرش به صورت میخی ساده هست. حتما از این نوع کابل استفاده بکنید به خاطر اینکه اینا توی متراژ های بالا تا نهایتا 100 متر میتونن سیگنال شما رو بدون هیچ نویزی ارسال کنن. یعنی هیچ نویزی نمیتونه روی این کابل های بالانس تأثیری بذاره. خب متاسفانه تا امروز هیچ کدوم از کیبورد های ارنجر یاماها از خروجی بالانس استفاده نمی‌کنن. پس اگر نوازنده ارنجر یاماها هستین اصلا این ویدیو به کار شما نمیاد. اما اگر حالا ساز کورد یا سازهای دیگه‌ای که خروجی بالانس دارن استفاده می‌کنید و این سازها رو دارید، حتما این فیش‌ها رو تهیه بکنید. من در ادامه یه ویدیو هست که زیرنویس و ترجمه کردم براتون میذارم، ویدیو رو ببینید حتما.
Some cables are capable of balance connections, others are not. In this video, we'll take a look inside some of the most common audio cables to see how they work. At the end of the video, I'll demonstrate how big of a difference a balanced connection makes over a long distance. All that's coming up, but if this is our first time meeting, my name is Kyle. Welcome to Audio University. There are many ways that noise can enter an audio signal chain. And one of the most common sources of noise is other electronic devices. When I place this transformer next to other electronic devices, some of the current passing through those devices is induced onto the transformer and enters the audio signal. The electric currents flowing through any device create magnetic fields that could induce currents on nearby devices. And we're honestly very lucky to have the cable technology we have today to prevent that noise from ruining our recordings. When connecting audio devices together, you'll most likely be using one of these cables: XLR, 1/4-inch TRS, 1/4-inch TS, or RCA. Let's expose the wires on these cables to get a closer look at what's going on inside. The XLR and 1/4-inch TRS cables both contain a shield, a positive, and a negative. The 1/4-inch TS and RCA cables each have a signal wire and a shield or ground. The construction of these cables is important to understand why the first 2 cables can support balanced connections and the second 2 cables cannot. In Handbook for Sound Engineers, Bill Whitlock shares this definition of a balanced circuit. A balanced circuit is a 2-conductor circuit in which both conductors and all circuits connected to them have the same impedance with respect to ground and all other conductors. The purpose of balancing is to make the noise pickup equal in both conductors, in which case it will be a common mode signal that will be made to cancel out in the load. If I'm being honest, when I first read this definition, it just left me feeling more confused. And that's probably just because I don't have a very strong background in electrical engineering. You might feel the same way, so let's simplify this a bit. In any circuit, you'll find a driver, a line, and a receiver. A balanced receiver uses a differential device, which will only respond to the difference in voltage between the 2 wires on the interconnecting cable. So, if there's a voltage on one wire and not the other, the voltage will go through. This is an example of a differential mode signal. If there's an identical voltage on each wire, they will cancel out in the differential device. This is an example of a common mode signal, which results in common mode rejection. Now this is where it gets really interesting because we can use this to our advantage. Imagine an audio signal sent across one of the wires. When it reaches the differential device, it's allowed to pass through because it's a different voltage on each wire. However, along the way, there's some noise from nearby electronics that induces voltage onto the wires. The voltage that's induced is equal in both wires, so the differential device will completely cancel out that noise. There are two important details that make this cancellation possible. First, the two wires have the same impedance, which means that the strength of the voltage will be equal in each wire. And second, the two wires occupy the same point in space, and they're the same distance away from the source of the noise, again, so that the strength of the voltage will be the same in each of the two wires. Looking back at these audio cables, we can see that each of them consists of two conductors. The XLR and TRS cables do both have a shield, but the shield is irrelevant to its ability to form a balanced connection, so let's ignore that for right now. If we look closely, we can see that the wires in the XLR and TRS cables are the same size. Given that the impedance of a wire varies based on its size, this suggests that the wires in the TRS and XLR cables have the same impedance. We can also see that the wires are twisted in the XLR and the TRS cables. This helps to ensure that the wires occupy the same average position over the length of the cable, so that any noise from nearby electronics will be equal in both wires. Before demonstrating the practical difference between a balanced and unbalanced connection, I want to make sure to mention a very common misconception about balanced audio. Sometimes an equal but opposite audio signal will be sent across each wire. While this has some additional benefits, it's not at all necessary to establish a balanced connection. The benefit of this is that the opposite signals will be summed together in the differential device. This is often said to be a requirement for a balanced connection, but in reality, the noise cancellation will still occur even if only one copy of the signal is sent across the audio cable. Now for a demonstration of the difference between a balanced and unbalanced connection. Right here, I've got 1,000 feet of 4-conductor cable, which gives me 2 pairs of conductors to work with. With a bit of soldering, I can wire one pair to be balanced and the other pair to be unbalanced. The balanced pair will be wired between pins 2 and 3 of the XLR connectors, and the unbalanced pair will be wired between pins 1 and 2. Right now, you're hearing my voice through the unbalanced connection. As you can hear, there is a lot of noise. Now you're hearing my voice through the balanced connection. The noise is still being picked up by the cable, but it's being canceled out by the differential device within the input of my audio interface. If you enjoyed this video, hit the like button.